So here are some instructions for the at-home solubility lab. This first picture gives us some science definitions of what goes into making a solution. So you might hear that you have a solution, a saltwater solution, and you probably know that that is salt dissolved in water. The science name for the substance that dissolves is called the solute. The substance that's doing the dissolving is the solvent. Water is often the solvent. We dissolve a lot of things in water. And so then together, when you mix a solute and a solvent together, you have a solution. So we might have like a sugar solution, right? We could dissolve sugar in water. Or we might have something, in our blood. There's all kinds of ions dissolved in our blood. Or glucose dissolved in our blood that goes around and feeds the cells. So that would be a glucose solution. All right, so you're going to, before you do the next part, click on these two videos and watch them. And then you're going to describe how salt dissolves in water. So we have a little picture here. And this picture represents a kind of chunk of salt. Salt is the formula for salt, and you can write this down, is NaCl, that's table salt, sodium chloride. These little gray ions are sodium ions, Na, and the little green ones are chloride ions, Cl. And sodium ions have a positive charge because they like to give up their one electron to the chlorine, which has a negative charge. And so you're going to describe why and take a look at these pictures. When water molecules surround a sodium ion, how is that different than when they surround a chloride ion? So look at the two pictures, watch the videos, see what is the difference between what they're doing here when they surround a sodium ion versus a chloride ion. And in the surrounding of those ions, that is the dissolving of sodium chloride. It gets broken up because each ion gets surrounded by water. Okay, so you'll write in your own words, your description here of what's happening after you watch those videos. Okay, so coming back now, factors affecting solvation. So affecting whether something can dissolve. So solvation, which is a sciencey word for dissolving, is the process of surrounding, you have to choose solute or solvent particles with solute or solvent particles to form a solution. So let's look up here. These particles, sodium and chloride, are surrounded by the water. So what is water? Water is the solvent, right? It's the thing doing the dissolving. So I'll give you one of the answers. Solvation is the process of surrounding something. What do we call the sodium and chloride, the salt, with the solvent particles? The water is the solvent. There's a phrase in science that says, water is the universal solvent, which kind of makes it sound like water can dissolve anything. That is not true, as we'll learn, but it does dissolve a lot of things. It's what we use most often as a solvent. Water is the universal solvent. Okay, solvation in water is also called hydration. And that's what we see in our picture up here. We see these hydrated ions because they've been dissolved. They're surrounded by water. Hydrogen, that comes from the hydrogen in the water, that word hydration. The attraction between water molecules and the ions of a crystal, so you have to decide what's going on here. Is that when things get dissolved here, is the attraction between the water and the ion, is that greater or less than the attraction how it was when it was just in a clump of salt? What has the greater attraction, the ions to each other or the ions to the water? You think about that. Then we have this phrase called like dissolves like. Polar solvents like water always dissolve polar solutes. They like dissolves like. Polar dissolves polar. Non-polar solvents, a really good example of a non-polar solvent would be oil. And they dissolve non-polar solutes. So you're going to do a little kitchen lab here, where you're going, there's just one part actually, you're going to test 4 different substances from your home to see if they dissolve in water, and then test them again to see if they dissolve in oil. And you can use any kind of cooking oil you have in the kitchen, olive oil, canola oil, safflower oil, anything, lots of other oils. And you're going to test 4 different things. Now, salt would be a great thing to test. So you have salt here, right? And we know from above that salt from the video, so for each thing you're going to predict whether you can dissolve it in water and oil, and then you're going to test it. So we know from the video that salt should dissolve in water, right? So our prediction would be yes. And then you're going to find out, can you dissolve salt in water? And then try dissolving it in oil. Sprinkle a little bit of salt in oil. You can put it on a little plate, tiny little saucer, or in a little cup, and try sprinkling a little bit of salt in there. See if the granules of salt dissolve, or do they stay as granules of salt. Then you have to, from those results, what does it tell you about the polarity of the substance? In this case, the polarity of salt. So if salt does dissolve in water, then you would conclude that salt is polar. If salt does not dissolve in water and dissolves in oil instead, you would conclude it's nonpolar. Now, a fun one to do here, if you have the opportunity, you've had that at home, is test a Sharpie pen or any kind of other permanent marker. And you can test it by drawing a little bit of Sharpie on like a little piece of glass, or on the bottom of like a ceramic plate, something where, no one would be mad that there was Sharpie drawn on it. And then you can see, can you clean it off with water? Does it dissolve in water? And then try it again, see if you put a little bit of oil on it, will it make the Sharpie dissolve? So that's an interesting thing. And then you can also try dissolving it with rubbing alcohol. See does the rubbing alcohol dissolve the Sharpie pen? So bonus, if you have a Sharpie pen, that can be one of the things you try, or it can be an extra thing. It's a fun one. So water, we know from what we've studied before with its water has an oxygen and 2 hydrogens, right? Sometimes we draw it with the hydrogens facing down, right? And the oxygen side is very negative, and the hydrogen sides are positive, because the electrons that they share, these 2 electrons in each bond, they spend most of their time hanging out around the oxygen, because the oxygen has a greater attraction for electrons. So water is a polar molecule, meaning one that has 2 poles, a positive pole and a negative pole. And oil is nonpolar. Now, rubbing alcohol is polar, but it's less polar than water. Interesting. So if you get the chance, if you have a Sharpie and you have some rubbing alcohol, or you can use hand sanitizer, which is made with alcohol, then you can see, does that make the Sharpie pen, does it wash it off? Oh, you could even try it on your skin. You could draw a little Sharpie dot on your skin. Does it wash off with just water? Does it come off with a little oil? If you put rubbing alcohol or hand sanitizer on it, does it come off? So, fun thing to test there. Okay, that's it.